Okay, good morning, everyone. I hope you can hear me okay. There's no Sam today, so what I'll do is I'll kick off with the same principle as last week. I know I've had a few emails through the week, but it's probably best to allow the students to just raise your hand, and then you can ask any questions of me. It's probably the best way to do it. So I'll have a look to see in the class list if there are any hands up. So if anyone would like to ask a question.
Sorry, Rod, could you record that as well, please?
Yeah, that's okay.
Thank you. And there's one hand up from Theo.
Let's have a look. Okay, so we've got Maya. If you'd like to ask your question.
Yeah, I just wanted to ask, can you explain how a worm gear would work?
The worm gear, yeah, sure. Can you see, I just want to check, can you see my visualizer? Can you see the paper on my desk?
Yes.
Oh, you can see that, okay. So let me show you. So the main purpose of a worm wheel is that you can, in fact, I'll ask you, why are you using the worm wheel, Ryan?
It delivers high torque. Also, it has a very big reduction ratio, so we need that for our design.
Right. So,
Rod, people still want to see the record symbol pop up for their team members.
Sorry, what was that? I didn't.
The recorder is still not. We can't see it's recording.
Yeah, I believe so. Okay. I mean, Thomas, if you make some points as well, just keep.
Yep.
If need be, I can always follow up with information, just posting stuff to Moodle, just to do this. But yeah, so the main thing with the worm gear. So here is the actual worm, and here's the gear wheel. So what you have is a situation where if you drive, look at it this way, it's probably easier. If you drive the worm, you can see that each revolution of this worm, if I bring that closer, hopefully that's better. Each revolution of the worm actually rotates the wheel by 1/2. So you can actually get huge gear reductions. The thing that obviously you'll note is that the drive is turned through a completely different angle. So if you're driving, say this at the end of the motor, which I suspect is what some of you may choose to do, and in order to get the motor speed right down to something that's perhaps a bit more useful, you would then need to think about the output of this wheel, because the direction will be changed. But the benefit is you can achieve these huge reductions, and you can see here, let's say one revolution of this worm is actually only going to move this wheel by 1/2. The gear reductions you can achieve suddenly leap right up to something like 60, maybe 70-1.
Right. I wanted to ask, how would we calculate the gear reductions? Like, do we just have sets like pairings, or can we kind of calculate and design our own ones?
You absolutely can design your own. There's no restriction other than really the suppliers that you buy from. And the only reason we put that in place is because of university purchasing rules. There was a time many years ago when, perhaps I first took this over, and we had sort of more of an open attempt to allow students to choose anything that, just as you would in normal everyday life. But the problem, you can imagine, you can soon run into problems. So the suppliers that we've actually put on there are the result of a reasonably lengthy procedure to get those approved by the university. So anything that is listed for purchase on those websites, as long as you give us the order details, the technical staff can actually purchase those over the summer. So that's the reason why we set that up, put the order forms there, so that you can then, with confidence, whatever you list, we can actually get. And it'll be very exceptional. You know, it'll be things like they've run out of stock that would prevent us from purchasing that. And that's why my understanding is that you had a talk from the technicians on Monday. So it's a chance for them to air some of the processing that goes on, you know, whilst you're sort of in quotes away over the summer, so that we can actually process all your parts and materials and have those ready for you at the beginning of the next academic year. So that's why I've sort of embellished what I was going to say, because I did have one or two emails about this. So that was really the reason. But I dare say, with whatever the technicians would have added on Monday, that will sort of reinforce why we're just focusing you on that. But, you know, if you wanted to design your own, because you had a very specific gear ratio that you felt you weren't able to get from the approved suppliers, then you could have a go at designing your own 3D printing. 3D printing maybe the worm, perhaps even laser cutting a gear, and you could actually have a go at doing that. So that's certainly up to the group.
We were able to find a worm drive, but we weren't able to find the wheel. So we weren't really able to understand what dimensions to use. It only gave us, the supplier only had like the mod mentioned, and we weren't really able to kind of calculate the width of the tooth. So it was really difficult for us. That's why it was pretty confusing. So I'm not really sure what the mod means or how we could find the pitch of the screw.
Well, first of all, these gears normally come as a set. So I think it's very unusual for someone to offer a sort of worm and wheel set without including both.
Okay.
Because as you can see, if you look at the end of the wheel, it has a slightly different profile to a normal spur gear, because it accompanies the worm. They go together. So I think that's unusual, I have to say, because I purchased these as a set. So the mod represents the module, and that is a relationship between the number of teeth and the pitch circle diameter. So once you've got a mod of a gear, that will then obviously determine the number of teeth that's actually around the pitch circle diameter.
Okay, that sounds good. Thank you.
And here's a separate, you know, worm. There's a worm drive. It's a little plastic one. I believe that was from Technobots many years ago. But you can see, because you've got a plastic one here, it's possible that you could, you know, I could still drive that brass wheel. I could still make that work. So if you can 3D print a plastic worm, if that's what you want to do, then you could try pairing that up. Probably makes sense to, I don't know, perhaps have that as a backup, as a backup plan, if you like. But that's certainly within the students' jurisdiction if they want to design their own. But bear in mind, so I did have a question during the week with regard to gearing, and you know, the table that we're asking you to launch across, you know, the zones that are there, you know, part of the reason for making that as big as we can is so that, you know, it does build in quite a bit of tolerance. So I wouldn't expect students to worry unduly about getting, you know, exceptionally precise gearing ratios, because the ball can land across a distance, both in X and Y. We're looking for sort of systems that are quite reliable, that show the sort of basic understanding of how these mechanisms work. So I certainly wouldn't, worry unduly about, picking a particular spot in one of those rectangles and making sure that, the gearing is exactly right, because there are other factors. You've also got the height at which you're launching. There's a little bit of aerodynamics that are involved. We're not expecting you to go into that. I mean, that all comes later if you haven't already perhaps started on the basics. But there are things like that which are all part of this project. But we know, given the time that you've got and where you are in your program, we're looking at slightly. We're looking more towards the practicality, the basic gearing. Have you been able to design something that meets the brief? Have you submitted a basic report? These are important skills, and you will build on these skills as you go through the academic years. So if you are designing something, don't worry unduly. It's the base. When you come to present it, we will be able to see clearly whether you've understood the fundamentals of mechanisms and the fundamentals of working, as a group to produce a product. So hopefully that helps, Mike. But please say if you wanted to seek clarification on that.
Thank you. That helped a lot.
Okay, so next we have Theo. If you'd like to ask your question.
Yeah, so when writing the report for the concept sketches, when we make them, they're hand-drawn and the annotation is hand-drawn. But when we put it in the report, can we have the annotations typed? I found that it makes it neater.
I suspect this is a moot point, because if you look at the ones that are on Moodle, the idea is that by careful use of graphics, you would then minimize the need for text.
Yeah, so I've only really got the title of what the view shows. So maybe if it's a side view or a plan view.
Yeah, because the idea is that you'll have at the center, you'll have your isometric. So hopefully you've got an isometric.
Yeah.
On that video. And then if you want to demonstrate, from the isometric, I have had one or two questions about how do we position it and will it show everything that you would like to, or you'd like for the markers to see. In some cases, or perhaps even in many cases, it will be unlikely that you'll see everything just from the ISO. You'll get a basic idea. So the little sketches that go around it, the little 2D sketches with arrows showing movement, maybe, like a little cartoon, that should then just demonstrate the functionality, the basic mechanism by which you're achieving one of the functions. So the idea is that you then don't need to put much text on. Okay. If at all. In fact, some of them, don't have any text on at all, other than, the title and the draftsperson. So I'm saying this because I don't want to encourage students to put loads of text on, because it is largely unnecessary. But if you really feel you don't have to print, like I said, I think I showed how to write with a ruler with the gearbox exercise, because the whole thing is giving you experience of creating something that, when you're away from the IT, you've got your sketch pad and you've got an idea and you're sitting in a cafe or something and you just want to sketch something out. You can do all that with a pencil and ruler, and actually be able to, through the use of graphics, communicate that to a third person. Otherwise, you could easily get carried away, not saying get carried away, and then end up typing a lot of stuff out, which really goes against the main purpose of creating a concept drawing. But if you really feel that you are struggling with your handwritten skills, first of all, keep it to a minimum, and you really want to type it out, then we will accept it. But we're not looking for that. I just want to make that clear. We're not looking to read explanations of how mechanisms works. We're actually looking for diagrams that show us how it works.
Okay, yeah, thank you. And as well, in the report, do we include a circuit diagram? I'm guessing it's going to be quite simple because there's only 2 motors really and a couple of components. But do we still need to include it?
That's up to the group. We haven't specified it because, as you can tell from the way in which this project has been steered, it's keeping students in the mechanical engineering space with minimal use of electronics and electrical input. So if you feel that you wanted to put that in, because that's something that you've done and you just wanted to show that, then by all means put that in.
Okay, thank you.
Okay. Next we have Daniel Thompson.
Yeah, hi. I'm sorry if this has already been answered before, but what would be the process to try and get a part that's non-listed available for our use? I mean, we could supply it because we only need a little rubber band to sort of act as a small belt, but who would we have to tell that to, or how would that be put on the order spreadsheet?
Okay, right, we've got 2 points there. The first point is that we're talking about an item which is part of your design. So let's take it in sequence. You'll demonstrate your assembly with a normal assembly drawing. So you might have a front view, end view, etc. And on the assembly drawing, just as you did with the gearbox, you'll balloon reference all your parts. So this rubber band or drive belt, whatever you want to call it, will be listed on your general assembly drawing. The next thing is that we've got to purchase it. Now, if you're absolutely sure that you're going to provide that yourself, then you don't need to list that in the ordering at all. However, if you want to ask for advice because it isn't listed in the approved suppliers anywhere, then you can email David Wood. So David Wood is one of the technicians, and he's actually coordinating all of the purchasing with his colleagues. And David might be able to recommend another supply, not a supply, but he might say, well, we've got some of these in stock and we'll provide that as a bath item. And he might give you a code or a basic description, and then you can put that on your University of Bath order form.
Okay, great. Also, something quick. What kind of details do we need to put on our concept drawing to identify it, like name or group number? Is it like it says on the 4-wheel drive example that we were given?
Yeah. So I'll answer this in terms of assessment. So the assessment mark that you will get for this particular project will be 20% made up of your concept drawing, and the other 80% of the mark will come from the group mark. So we must be able to allocate that concept mark to the right individual. So please put on there your name, and if you've got your candidate number, that would be useful. Sometimes students put on their longer, I think it's 11-digit student number, but all we're really wanting to do is link the mark that will go with that concept drawing to the right individual.
Okay, brilliant, thanks.
And then it's up to the students. If you want, I think I've put what I hope is a natural sequence of events as part of the report structure. So if you're scanning those in, you can scan those in whatever it is, chapter 2, chapter 3, but just make it absolutely clear. Be very bold with the name of the author on the concept drawing, because as you can imagine, we've got quite a few items to look through in this as part of the assessment process. So we're just trying to do that as quickly as possible. That would help us if you can do that, Dan.
Okay, thank you.
Okay, let's have a look. I can't see any other hands up at the moment, but whilst I'm online, is there anything that you would like to ask, if there's anything at all? I'd say the chances are, if you're thinking it, then other students are thinking it, so do feel free.
So I was just going to say, while people think of questions, maybe you could answer some of the chat ones. So the first one would be, is there a word or page limit for the report?
I haven't put a limit on it. The idea is that the way in which this activity has been set up is that it's mainly geared to drawings. There might be a few calculations. You know, there are meeting notes. These are things that I'm hoping aren't going to get or become very text-based. So I haven't put a limit. I mean, if you put stuff in that's all relevant, then we'll read it. In terms of reading it and assigning marks, if there's lots of stuff that's irrelevant, then obviously it won't gain marks. So I haven't put a page limit or a word limit down. I mean, typically it's quite tricky because you know, as we had with the previous question, who asked if they could put down a circuit diagram, you know, that would then potentially add another page in. But because it's relevant, we have no problem. We'll read it and we'll make a judgment on it. But typically pages tend to be the main report, you know, can vary, things that can vary between pages like 12 and let's say 20, that sort of range. I think if you're going outside of that range, you just need to just double check that you're not saying stuff that's irrelevant or you've missed stuff out. Now, students might decide to put the part drawings in the appendices, but the main sort of body of text or main body of pages tends to be something between, let's say 12 and 20. That sort of order. But it just depends so much on how students want to structure the report. Like I say, appendices are useful, but I've tried to set it out so that as you go through the natural sequence of activities, you can just chuck those into sections or chapters to then form your report. We're not looking for loads of description because most of what you are doing can all be explained with drawings, simple calculations. Yes, there will be a concept selection, but again, you could have a few matrix. You've got some sort of process by which you can come up with the chosen design that can be numerical as well, mostly numerical. So we know what these things mean. You know, if you wanted to, or if you felt as a group there was a main learning point as you're going through this and you want to make that clear in the report, then that's absolutely fine. You can put that in. Just as much as your working and experience of working as a group. Now, we know that there's a little bit of space to all groups, as we do every year, so that you can organise yourself. The assessment criteria makes a point of, let's be specific. In the assessment criteria, there's one engineering drawing each, one part drawing each. Now, the idea of that is to also help spread the work, you know, across the group, because it's very easy for one person to say, yeah, we're good at CAD. I mean, hopefully you're good at CAD after the more intensive use of CAD in semester one, but it then avoids one person having to pick up all the drawings. And, you know, we know that the last thing to probably be designed is going to be the part drawings. There will be some finishing off of the report, but that will be towards the end of the line. So we're hoping that not one person is left to pick that up, that it gets distributed across the group, so you can share that last phase, you can share that across all members. Now I say that whilst being mindful of the question I think Daniel asked last week about, I think it was Daniel, forgive me if it wasn't you, Daniel, with regard to a group organising themselves and deciding to allocate roles whereby one person might take more of the CAD. And I have absolutely no problem with more of the CAD. And if the group feel that that was an amicable distribution of work and workload, then that's completely fine. So as part of the description, and certainly even in the conclusion, please put that in. And then we will understand if, I mean, hopefully you won't break the rule of not at least having one part drawing for each member of the group. But if you then want to make a point that, look, we found that this style of managing the process worked well for us, and this is what we did, and you want to conclude, make a conclusion, then please put that in the report. I mean, that's quite nice to read. Just as, you know, if you want to put in the conclusions, what your final cost was, and what you felt were the, you know, the proportions, you know, that's something you can conclude on, put that in. You might want to make a comment on the process principle that you finally chose. Maybe some comment on how well that worked as you're going through the report. You know, that's absolutely fine. So that sort of text, that sort of extra description, wordage is all completely fine. But we're not looking to put a word, and the reason is some students might see it as a word target, and in this particular exercise, I think you've got enough actual activity to complete and do as a group, as maybe as individuals. Then when you, by the time you add all that together, we can then see that you've gone through the design process. And that's what I think is the nice thing about this exercise. You've now been able to go through the whole design process, which will finish in semester 1 next year, when you actually do a bit of a build and you present the prototype, and you can see all of that firsthand for yourself. So again, you know, there's latitude, deliberately there's latitude in the group, because otherwise it defeats the object. If we're starting to constrain you too much, then we will know what you're going to do and won't give you the opportunity to problem solve with a lot of breadth. And we want you to feel that, you know, you hold the reins, you've got the budgets, you've got the resources at your disposal, and you know, when you demonstrate the prototype, it's going to be yours, it's not ours. And indeed, when you, I think from most of you looking for figures, you go on placement, perhaps you have an interview beforehand. You know, they might want to talk about some of the practical stuff that you've done on the course, in addition to some of the theoretical units. So, you know, as it's going to be your design, you'll be able to speak about that more convincingly. So, again, if there's something you feel that is directly relevant to the report, then put it in. If you really get stuck and you're worried about this, then just email me. That's not a problem. And if you want to come back to me on that, then obviously raise your hand or put something in the chat, and I can clarify something for you here and there, need be. But otherwise, I'll consider that the full answer, Thomas.
Yep, that sounds good. Perfect, thank you. Next one was about laser cutting prices. Do you know if they have, for example, just a single gear, so a small gear? Do they need to account for the whole MDF sheet, or is it all right if they just account for that small area of it?
Yeah, I put this up on Moodle a couple of days ago. The idea is that you've been given acrylic sheets to use, so you can continue to use those. There's no problem. And you know, there is an example of what students have done. They've been able to get some spurtic dimensions and cut from acrylic. So you can still do that. I had a few questions about MDF. Now, the general rule is we're trying to steer you away from wood per se. However, there may be instances where you know, you could use MDF, and I checked with Gary. He's happy that we've got a supply of it. We're not deliberately guiding you down that way. There's no cost benefit because it's not part of your budget. So what I've said on Moodle is the cost is pro rata. I've given you a cost for an MDF sheet, 900 by 600. So what you would do is just work out the area that your particular part occupies, and then just divide that up, or divide that by the cost of the whole sheet, and then you can work out a part cost, a material cost. There's no, for now, there's no other cost. There's a little bit factored into the cost of the sheet, so that's all you need to do. So for a tiny little part, you're using whatever fraction that is of the total sheet area of the price that's up on Moodle.
Okay, perfect, thank you. Next one was for the 3D CAD model, do they have to consider assembly constraints?
Have they got any more detail on that?
No, maybe it's worth for the person who asked that to jump on. Otherwise, in the meantime, there was another one on the CAD. So
just before going on to CAD, I'll give them an answer because I think I'll anticipate what I think the student means. But if I've misinterpreted it, I apologise. But you can then just clarify that through the chat or raise your hand, because these are quite nice things to talk through. Now, what I think the student means is that they've got their basic parts in position and they're not sure about extra level of details they need to go to in terms of putting in nuts and bolts and rivets and things like that. That's what I think you mean. Now, the reason I've asked for the 3D CAD is because in the marking process, we've got your assembly drawings with your front view, end view, and all the rest of it, and that will show a lot of detail. But prior to that, it's really nice if we just get you to print out the 3D model, because it allows us to see very quickly and more realistically what it is that you've designed. Now, because you would have built that model up and all the parts will be in place, then that will be fine. But I know that when you actually come to make it, there will be little nuts and bolts and other little assembly fasteners that you will specify and use to actually build your prototype. But I suspect what the student is saying, that they might have all the basic parts in place, but they haven't gone through to the level of detail of fastening. So I wouldn't worry unduly. I mean, clearly, if students have put in the nuts and bolts, and I believe certainly when we're using Solid Edge, I mean, you can download nuts and bolts as part of the macro setup. So it's relatively straightforward for you to do, but it's not a hugely important thing if you haven't done it. So if you then finish all your part drawings, your assembly drawings, and then haven't quite got time to put every single nut and bolt in your main 3D shape, then don't worry about it. We would just like to see the basics of how your product is going to work. I think that's what they mean, Thomas.
Yeah, sounds good. Stay on CAD then. So for the whole thing, do they just need to make screenshots of the different sections of the 3D drawing, or do they also need anything else from the CAD? I guess that is kind of linking up with other points you made about part drawings as well.
Yeah, so what you'll deliver will be the 3D CAD. So I know this year, it probably is a good question to go over, because for the first time this year, you've been given AutoCAD. So it might be that some groups have gone down that route to produce their assembly and part drawings, and now are working effectively backwards to produce your 3D model. So I would I would say if you've then sort of worked backwards and gone into Inventor or even Fusion 360 and built something that sort of represents your 3D model, then I think the easiest way is just to take a screenshot from one direction, rotate it round, take another screenshot, and it might be that you can fit both of those on one page. Or if not, put them on a page each, A4 sheet. And then that will give us a very quick and clear understanding of the basics of how your product is going to work. Now, if you've started off in Inventor or Fusion 360, then you'll get this for free. And there was a question I received. I can't remember if that came through Moodle or whether I received that in my personal Outlook. But we were talking about the level of finish. Now in CAD systems now you can render. Well, I say now, it's been done for years. You can render and you can put all sorts of effects on. Don't worry about having a photorealistic finish on your 3D model. That's not what it's for. If you happen to color sort of, not all of the parts, but maybe some of the parts, just to emphasize key parts from each other, then that's absolutely fine. You can render, you can put different finishes on the render, keep them simple, keep them as simple colors, maybe even simple shades of gray, just so that we can distinguish them easily when we actually come to look at it, because it's quite a nice thing. It's a bit like this wheel. You've got, could be a yellow, light orange sort of finish. That would be fine. Don't worry about having to import it into Photoshop and have a nice glassy finish. I mean, if you can do that and you want to do that, I'm not limiting you to it, but just use the basic rendering and finishing techniques that are already within the CAD system, and a few screenshots will be absolutely fine.
Okay, perfect. Thank you. A couple more on the report. Did I need to include an introduction or conclusion section? I think you partially answered that previously, or should they not consider that at all?
It is a report, so please treat it like any report that you've done. Every report should have an introduction and a conclusion. The other sections are determined by nature of the exercise. So I put down something which you can use completely. The structure that's posted to Moodle can be as simple as the activity that you're actually going through, so that's fine. So what you put in the middle is okay, but the rest of it should be a report structure. You can use appendices as well, but I've largely put that structure in so that it follows the natural sequence of activities that you go through. You'll see in the assessment part that a relatively small contribution made for look on the assignment here, what have I got? Reports is 30%, but you'll see it contains the specification, the development, record of meetings, cost. So we're looking at the elements within the report, and the basic structure of the report will be part of that, but it'll be a small thing. So yeah, please don't worry on Julie. If you felt that one of the chapter headings wasn't accurate or something like that. I mean, the main thing is it is a report, so it should stand alone as a report. Remember, the way to look at this is you're giving this to a third person, so they're not familiar with what you've done. So a paragraph just introducing what the project is. I think I've said previously that you can make space for the specification, put that in the introduction. That's absolutely fine. And you clearly state what the aim is, what the objective is, just as you would do in your lab reports. But we're not expecting, 5 pages in the introduction. Introductory paragraph, maybe a bit of explanation, another paragraph, got the specification, a couple of words, another short paragraph. That's it, done. Move on to the next one. And the conclusions, again, it could be got half a page, but that could be maybe 3 points, 4 points. Part of it, what I've already said, so I won't go over that again, what I've already said today. But again, it stands alone as a report. Which of course, we've already taught you on, so there's no need to go into the detail of that. Hopefully, you've already mastered that and you can do something relevant, proportionate to what we're asking of you. And like I say, you can lean on the report structure that I put on Moodle.
Perfect, thank you. There's another one on the report, which is for the rationale for the chosen concept, what format is expected. Should it be a short paragraph explaining why, or can they use a selection matrix done as a rationale?
Yeah, the selection process is, I think that's been taught to you by Elise. So I don't want to sort of contradict anything that is in the lectures from Elise. So whatever has been taught to you from that, I would expect you to apply that to this particular project. I mean, if Elise, I think that was Elise I heard at the beginning. Elise, if you're online, you can perhaps answer this one now.
What was the question again? So can you reiterate, Thomas? I
Yep.
was doing clicking away in the background on some other things. Yeah.
Right. For the rationale for the chosen concept, what format is expected? Should it be a short paragraph explaining why, or can they use a selection matrix done as a rationale?
Yeah, I mean, I do think, Rod, that's a question about what's required in the report. So if they have the selection matrix, do you expect them to write a short paragraph in the report to illustrate what has come out of that selection matrix? I'm not marking it, but I would say that is the normal practice. So the selection matrix goes in as a figure, and then it's normal practice to describe the figure in the same way that you do for any technical report. Any table or figure needs to be referenced in the body text, right, Rod? I mean, that's standard technical writing.
Yeah, that's the same as you would have had for your lab reports.
Yeah. So I think the answer is, if you've done a selection matrix. Who's the question from? Thomas?
That's a very good question.
Okay. If you've done a selection matrix, you would include it in the report, but you need to draw your conclusions from the selection matrix in a short description for Rod.
So, I mean, if the student wanted to
Speak
ask
up.
It's from my.
Okay. So the other question that did Rod that did, now that we're on this, but that came up a couple of weeks ago, was that some of the students had forged on quite quickly, and they've done their down selection by listing pros and cons for each of their concepts. And I confirmed that I was not expecting them to go back and then also do a selection matrix. So if they've done a fairly robust systematic pros and cons of each of the concepts, as long as that was fully reported in the report, you would be happy with that.
Yeah, because it's part of the process of selecting.
Yeah.
Effectively, you're going to go through as a group. You're all going to have your individual concept drawing, and then you've got to choose one and then develop it.
Yeah.
We know that it's normal to have some sort of process to help you make that decision.
Yeah.
Whatever it is, I think it's acceptable. Just put that down, make it clear. Now, it goes back again, because this is completely relevant, goes back to the idea of text and what you should put. Because it's completely relevant, if you just want to put a sentence or two saying, look, this is just describing the process that you've gone through, and then here it is, here's our chart, if that's what you've done, if you've decided to make a pros and cons list, and then you've made a decision based on that. If that's what you've used, then that's fine. You can put that.
Yeah. Yeah. So I think some students had progressed to that stage before I uploaded Design Methods 3. So I was suggesting that we were definitely not expecting them to artificially go backwards in their design process. So they should just forge forward and report on how they did the selection themselves. But Mai is happy with the answer. She's put that in the chat. So thanks, Mai, for the question.
Yeah, thanks, Elise. Hopefully that's clear to anyone else. I mean, as there are a few of you online, if you wanted to add to it or just ask us to clarify something, then we can do that now. And if not, we can answer another question if you have one, Thomas.
I think I only got one more so far, yeah. So for the motors, would you prefer a series or parallel arrangement of them?
That's completely up to the group, how you want to do it. I appreciate what you're probably trying to do, but like I say, it's not for us to interfere with your design. It is yours, and I know there are certain advantages by putting them in parallel. So and the other configuration, but that's completely up to the group. If you decide to do something like that, then it's nice to just have a very quick bullet point as to why you've done it. That's the basic nature, I think, of this exercise. We know there are a myriad of paths that you can go down and decisions that you can make. And it's really the thought process that's actually quite useful, as well as just seeing what you've ended up with. So just a very short, punchy line on why you've done it. As someone said earlier, they might want to put in a figure showing the circuit diagram, wiring diagram. That's absolutely fine. That would then go quite nice together, and that's quite nice to read, actually. So yeah, I think it's definitely up to the group to you tell us why you've done it. Well, we're getting close to the end anyway. The 12:05. So I mean, if there is one more, Thomas, I'm happy to take it.
There is one more that just came in. Are they only allowed to use one battery?
No, I haven't put any restriction on batteries. I've put restrictions on motors, but not on batteries. It might be you start using the multiple AA batteries, and also don't forget to specify the cartridge that they're going to be held in. We can soon get hold of one if you did miss it. I suspect we might even have a few old ones left over, but the AA batteries or AAA, if you're going down that route, or PP, PP3, then you specify. Well, it's more for the AA, the cylindrical ones. There are cartridges that will hold all those for you, so specify that. But how many you want to have, that's completely up to you. As long as you're within the spec, of course, for the voltage.
Thank you. And then I just saw another one, which was a bit of a confusion from Monday's technical session with the technicians. It seemed that there was more trend for going for MDF rather than acrylic.
So that sounds like an observation. What are they really? What is their concern, Tom?
So their concern is, should they use acrylic, I guess, rather than MDF, or should they use MDF rather than acrylic? Based on, I think today it was more like go for acrylic, but Monday was more like go for MDF.
Yeah, I mean, up until a couple of days ago, MDF wasn't on the list. But I know one or two groups, so we're not talking many, for whatever reason, we're looking to use MDF. What I don't know is why. I have to say that. So
Rod, it was the technicians prefer people to use MDF. It's really easy for them to produce a lot, components cheap, a lot of components cheaply. So I think it was my interpretation. I don't know if you agree, Thomas, that Monday the technicians said, if it's not critical that it needs to be acrylic, go for MDF and then go for acrylic.
Yeah, I think so. It was more that I think David was kind of like not sure if it's acrylic or MDF, and Gary was like, no, the price is listed on Moodle are all for MDF, so that's the preferred option, sort of.
yeah, from the assignment point of view, there is no preference.
No.
It's up to the group. If you wish to choose to make your parts out of acrylic, then you choose it. I mean, we have a budget for these things, and we've actually run that like that for a few years now without any MDF. Now, the point that Gary's making from a manufacturing point of view, if it saves, you can see yourself what the cost is. I don't know, if you really wanted to, you could do a comparison. You could list all the parts that you've got in acrylic, cost them out. You could compare that with the cost for MDF, and you could even in your report make just it's a very short thing, just make a comparison of cost saving if that's considered to be a point worth making in your report. But it's really up to the group. And like I say, in recent years, it was only acrylic that was on the resource list. But I did have, I know I'm repeating myself, but I did have one or two emails where students were sourcing MDF and were looking to do that from the supply list. Now, it's something that I really felt was of no great advantage to the students. And I didn't want you wasting time trying to source an MDF from a supplier, an external supplier. So I thought the simplest thing is just to check with Gary that we do have it, and then just to put that on Moodle for you to save you time. But that was in no way trying to influence the group that they should use MDF. When years and years ago, all sorts of things were being used. And there was one year where we had sort of mechanisms, and we did have wood, plywood and all sorts of things. And there were mechanisms inside. And when it came to assess, it was a shame really, because we couldn't really see a lot of the mechanisms that students had used, and particularly if parts and components were being passed through them. And so in some ways, the use of acrylic was quite nice because it was transparent largely, and they enabled us to see working mechanisms. Now, I appreciate that's not always going to be possible, but there certainly is an advantage from that point of view and being able to demonstrate and show your product. So it's without influence that MDF has been put on there. And from my point of view, it was purely to save time for students that had decided that for whatever reason, they wanted to use it. As Elisa said, there apparently on Monday, there is some advantage from the manufacturing point of view, but that still shouldn't influence you. That really is an aside. That's something that we do regardless. So hopefully that's answered that. I don't know if they've come back on that, Thomas. I'm happy to.
Not really. Okay, yeah, it's fine. Thank you.
Okay, all right.
before you clock off. There's actually two more hands raised, but before I clock off, because I have something else today. I'm not, so Monday is also free if you wanted to run your loyal next week on Monday, because, you know, according to our schedule, I'm finished now. So in theory, you've got Monday and Wednesday next week. So I don't know if you're going to make an announcement of what your intention is.
My intention was to keep it as it is.
Wednesday, okay.
But thanks for letting me know, or confirming. As always, we've got Moodle and questions can be posted there, so there's no need to wait. I mean, this session was really, it's about just being able to talk through and give students a chance to make some sort of more humanistic interaction. The idea of getting questions answered, you know, you can do that through Moodle at any time, so there's no problem with that. But okay, we've got Oliver. Oliver, would you like to ask your question? Oliver, sorry, we've got two actually. Oliver Jones.
Yes, hello. Sorry, just had a really quick question. So obviously a lot of the motors on Technobots have a gearbox built into them. Does that negate the considerations for axial loads on the output shaft? Does the gearbox prevent an axial load from going on the output shaft? So is that sort of the best solution to it, just to get a motor with a gearbox attached?
Unfortunately not, Oliver, because that shaft again will still have a need really to operate without undue forces. So
I see. Okay.
So I think on this one with what we've got 62-1, but that is obviously with the gearbox, the little gearbox in. So
yep.
Here I've just attached, and you see on Technobots we've got all sorts of couplings. So you would want to do something in addition to that.
Okay, thank you.
That's what I would say. But it's a fair question. I mean, if the gearbox was set up in a way, but to be stronger, if we knew what those bearing forces in the structure was, we could possibly look at make a calculation to see what sort of force we were applying. But you can't rely on that. We actually don't know that. And there may be things that you won't know about yet, but you'll see when you come to make your product that will apply extra forces. And that's why it's better to do it as a design feature, a separate design feature, independent of the primary drive unit.
Great, thank you.
Okay, we've got another Oliver. So Oliver White, would you like to ask a question?
Yeah, hello. I was just wondering, you said to write the report similar to the way we've been taught to write other reports. But in those, I've been told not to use the word I when I'm sort of describing how you're doing the experiment. Would that be the same for this? Or can we say like, we've decided to do X and stuff like that? So I guess it's a question about wording.
Yeah, no, it's a fair point. As a sort of broad view on the reports, the writing style, they should be scientific. They should be scientifically written. So you have to avoid first person. So you have to avoid I, we, and things like that. Even though if we read it, we would have a greater sense of what the group was doing, and you know, all that sort of live, almost creates a certain live sense to it when we're reading through. But because of the nature of the course you're on and the type of things that you'll go on to study and research, and you know, if you go on to write articles, journal papers, etc., these all have to be scientifically written. So yeah, please avoid first person. It's all neutral. So you could say things like it was decided. You could even say the group, but generally we're trying to not bring in any personalization within the report. So things like it, or the next step was to take this. So things like that is to be used in the reports, please.
Yeah,
we appreciate that you're on a learning curve, and there might be the odd slip, and even in some of the lab reports, there might be the odd, you might forget yourself and do that, and we'll circle it. But we're all generally getting you to write in or with scientific language. So yeah, if you can avoid that, that'd be great.
Yeah, cheers. Thank you.
Okay, so we're slightly over time, but that's not a problem. There are no other hands. So thank you all for your questions. Like I say, you could always post something on Moodle if need be. But otherwise, good luck with carrying on. And as it stands, I'll open this up again on Wednesday. And if we decide to use Monday, I'll make it clear on Moodle.